This video is the last installment of the chain rule applications. There's two problems. They're fairly large problems, so let's get started. So for what values is for what intervals are the values of this graph increasing and concave down? So let's look at increasing and concave down. So we know if it's increasing that your first derivative is greater than 0. Okay, because my slopes are positive. If it's concave down, my second derivative, which is for concavity, is less than 0 or it's negative. So you know we're going to have to do derivatives to answer this question. And so when I look at this function right here, I see that it's a product rule. And within the product rule, we're going to be doing the chain rule. So let's get started with the derivatives. So I have f prime of x. And if this was f and g, so I have f is going to equal x, f prime is 1, g is e to the negative x, g prime is going to be, rewrite it, times the derivative at the top, which is a negative 1, so it comes out negative e to the negative x. Okay, so if I do this, I got f prime g, so I have e to the negative x, plus f of g prime, which turns negative, negative x e to the negative x. So I just did the first derivative. Now what we have to do is put this equal to 0, but before I do that, I want to factor this to make it a little bit easier to do. So I got e to the negative x, I'm going to factor that out. I have 1 minus x, and I'm going to put it equal to 0 to find out at what points the slope is 0, so I can find the increasing and decreasing. If I looked at this piece right here, e to the negative x will never equal 0, so thanks for your help, thanks for playing. This is 1 minus x equals 0, so x equals 1. So right at x equals 1, there's going to be a turn of some sort, a curve, so that the slope is 0. Now we want to do the second derivative because we're going to have to find that information. And what I want to use is this one right here to do the derivative with, because you don't want to, this one will make it more complicated. Here we can do the product rule again. So if I do the product rule for the second one, so let's do the product rule right away here, and then I'll do it underneath. So f is going to be e to the negative x in this case. F prime is negative e to the negative x. G is going to be 1 minus x. G prime is going to be negative 1. So now let's do the second derivative. So it's a product rule, excuse me. So it's f prime g, negative e to the negative x, times g, plus f g prime, but it's a negative 1 times that, so it's negative e to the negative x. And I want to factor this also. So here's a term right here. I'll use a yellow here. This is a term right here, and this is a term right here. And I see that they both have in common a negative e to the negative x. So I'm going to factor that out. Negative e to the negative x. When I take that out, I have a 1 minus x left in my first term. If I take it out there, I have a, if I take a negative out of a negative, it turns positive, and it's a positive 1, and we're going to put it equal to 0. So I have negative e to the negative x times 2 minus x, and it equals 0. Make a big T. So negative e to the negative x will never equal 0. So thanks for playing, thanks for your help. But I do know that 2 minus x will equal 0, so x equals 2. So here are the 2 points here that we can use on our f prime bar. So I'm going to make a nice big graph over here of this function, excuse me. So I graphed it, and then I'm going to put my f prime bar underneath it, and my f double prime bar underneath it, so that we can go through and see when it's increasing and decreasing. And the graph kind of looks like this a little bit, so kind of look like that. This is 1, and so we did 1 here for the f prime bar, and then the other one was 2, so that would be 2 right here. And let's go through this. So I'm going to look at the blue here. I'm going to change this right here. Keep this yellow right here, for this is our second derivative right here, and our first derivative is up here. So if I look at the blue up here, and I want to use left of 1 and to the right of 1, if I go to the left of 1, we'll pick 0. This would be positive, okay? And this would be positive, so it looks like it's positive here. If I go to the right of 1, we'll pick 2. This would be negative. This is positive, so this is negative. And according to our graph, if it's positive, this means my function is increasing, and this means my function is decreasing. And our graph kind of shows that. Now let's look over for our f double prime bar. We'll look over here at what we have here in yellow. If I go to the left of 2, all right, like a 0, this is going to be positive and positive. Excuse me, positive times a negative. This would be negative here. If I go over 2, this is negative times a negative. This will turn positive. Now remember with f double prime, this means my function is concave down. And this one's concave up. So now we have to look, what did they want us to find? Increasing and concave down. So the increasing would be, we'll use blue, the increasing would be right here. So the increasing would be, whoops, undo that. So the increasing would be right here, and then it says concave down, so that would be here to here. So when does both happen? Well, it's when it's less than 1. So my answer is going to come out to be from negative infinity all the way up to 1, our function is increasing and concave down. So there's one problem using the chain rule. Okay, this one is another one, very similar problem. I have, well, for what intervals is f of x 1 over x squared plus 1 concave up? So now this one's just asking us about concavity. So if it's just asking about concavity, all I have to worry basically is about our second derivative. It doesn't mean it has to be greater than 0 and it's got to be positive. It doesn't mean I don't have to do my first derivative, it just means I don't have to put it equal to 0 and solve for it. So let's start with our derivative, first derivative. I get f prime of x is going to be, and this we're going to use the quotient rule, so there's our f and g's. So I'm going to say f is going to be 1, f prime is 0, g is x squared plus 1, g prime is 2x. So if I did f prime g, that's going to go away, minus f g prime, that's a negative 2x, all over g squared, so it's x squared plus 1 squared. I just found the first derivative. I don't have to do anything with it because I just want to know if it's concave up, but I did that. Now I have to find the second derivative. That's going to take a little bit more work, so here's our f and g's here again. So f is going to be negative 2x, f prime is going to be negative 2, g is going to be x squared plus 1 squared, g prime is going to be the power rule, 2, don't touch the baby, to the first, times the derivative of the inside, which is 2x. So g prime is going to be 4x times x squared plus 1. Now, whoops, sorry, let's put this in our derivative. So I got f double prime of x is going to be f prime g, so it's negative 2 times x squared plus 1 squared, minus f g prime, but since it's already negative, it's going to be plus, and it's going to be 8x squared times x squared plus 1, all over g squared. So if I did x squared plus 1 squared squared, you know it's going to be to the 4th power, but let's just take baby steps here. So I got f double prime of x is going to equal. Now, I am going to look at this. I have a term here and a term here. I want to see, can I pull something out? Well, I can see they both have a factor of 2 out. I can take that out. And they have x squared plus 1. So I'm going to take out, actually, the negative 2. And I'm going to take out an x squared plus 1. And when I do that, what's left over of this one is I've divided that out. I just have 1 x squared plus 1 left. If I divide by negative, this turns minus. And that gives me a x squared left here. Excuse me. If I do this here, I've got the x squared plus 1 is out. And then I have a negative 2 divided by it, so it's just going to be minus 4x. And it's going to be squared. Okay? All over x squared plus 1 to the 4th power. Now I'm going to continue to simplify this. I got f double prime of x is going to be negative 2. And if you'll see this, this can cancel out and this goes to the third power. So I have negative 2 times a negative 3x squared plus 1 all over x squared plus 1 raised to the third power. So we have our second derivative here. It's done. Now we have to put this equal to 0 and do 0 over 1 if you want, so you can cross multiply. You would see that you look at the numerator and say, okay, negative 2 times a negative 3x squared plus 1 has to equal 0. Make your big T here. Negative 2 will never equal 0. Negative 3x squared plus 1 equals 0. So I have 3x squared equals 1. Divide by 3. I have x squared equals 1/3. Square root, I have x is going to equal plus or minus radical 1/3. So that's what we're concerned about. Now over here on the side here, I'm going to kind of draw a nice big picture of what this graph looks like. And the graph kind of looks like this. If I can draw it, do it justice. And I only want to know when this one's concave up. So we're only going to put the f double prime here because that's all we had to worry about. So this is f double prime. We don't have to worry about the f prime of x. So we've got a negative radical 1/3 and I have a positive radical 1/3. Okay? So I've got to check and see what's happening with this. So as I do this, if I go to the left, and I'm going to use right here, I'm going to use this to plug the numbers in because it's in factored form. So if I went to, we'll say, a negative 1 and put that in there, this would turn positive. A negative plus 1, so this is negative times a negative. This would be positive. And it'd be the same if I picked a positive 1. It's still that. It'd be a negative here times a negative. This would be positive on this side too. In the middle, let's pick 0. If I pick 0 here, this would be positive times a negative. This would be negative. So this is telling us this is concave up here, concave down here, and concave up here. So I want to know, when is this function concave up? So it's concave up here and here. So I'd say my answer is going to be from negative infinity all the way up to negative radical 1/3 in union with radical 1/3 all the way to infinity. It's concave up. It's only concave down in the middle, so there is our answer. That concludes this video on applications.